Good morning to all. Today we are discussing about specifications of digital to analog converters. In this, the first specification is resolution. Resolution can be defined in two ways. In this, the first way is resolution is the number of different analog output values that can be provided by a digital to analog converter. For an n-bit digital to analog converter, the resolution is 2 power n. It means that, for example, here we are consider the digital to analog converter circuit, and here we are giving the input is the digital bit, and here we can get the output is the analog output signal. Okay, and for example, here we are giving the input bit consisting the total number of bits is 2 bits. With respect to these two input bits, we can get the total possible combinations is 0 0 0 1 1 0 1 1. Okay, for example, we are giving the input is 0 0, we can get the analog output signal is 0, and similarly if we are giving the input is 0 1, the analog output is 1 volt. Okay, and if we are giving the input is 10 bit, and then we can get the output is 2 volts of analog signal. And similarly, if we are giving the input bits is 1 1, then we can get the output of this analog signal is 3 volts. Okay, so here we will get these voltages by using the output voltage expression of this digital to analog converter is V0 equal to minus reference voltage of B1 into 2 power minus 1 plus B2 into 2 power minus 2. So in this formula, we are substituting these values, then we will get these analog output voltages. Okay, and with respect to these inputs and output, we are drawing the digital to analog converter response. Okay, so here we are consider the digital input bits, and here we are obtaining the analog output voltages. Okay, coming to this digital input bits, we are giving the input of bits is 0 0, we can get the output also 0. Okay, and similarly if we are giving the input bits is 0 1, then we will get the analog output voltage is 1 volt. And again we are giving the this input digital bits is 1 0, the output is analog 2 volts, and if you are giving the 1 1 bits, then we will get the analog output voltage is 3 volts. We know that this analog signal not linearly varying with respect to this given input digital bits. So here the analog signal suddenly move from 0 volts to 1 volts, and again it move from 1 volts to 2 volts and 2 volts to 3 volts. Okay, and now we can observing this digital to analog converter response, it will look like a staircase waveform. Okay, and here we are observing one important point is if we are giving the input is 0 0, we can get the output is 0 volts, and similarly if we are giving the input is 0 1, we can get the output is 1 volt. Now we can comparing these two input bits. Here input is 0 0 and here the input is 0 1. If you are comparing these two inputs, only one LSB bit can be changed. This LSB bit can be providing the analog output, that is we are considering as a resolution. Okay, and now here with respect to these given inputs, we can get the total number of output voltage levels. How many here? 4 levels are not. Here we are giving the input bits is 2, then we can get the total analog output voltage levels is how many? 4. So we can get 2 power 2 equal to 4. Similarly, in this digital to analog converter, we are giving the total number of input bits is n bits. Then we will get the resolution equal to how much? 2 power n. Okay, and other definition of resolution is also defined as the ratio of change in output voltage resulting from a change of one LSB at the digital input. It means that here already I am explaining, here we are giving the input is 0 0 0 1, here we can get the output voltage is 0 volts and 1 volt. If you are comparing these two input signals, only one LSB bit can be changed. The change of this LSB can be caused the obtaining the analog output voltage, that is we can considering as a resolution or step size. Okay, so the resolution or the step size of in the digital to analog conversion is output to full scale voltage whole by 2n minus 1. So here this 2n minus 1 is indicating the total number of step levels in the digital to analog converter response. For example, in this response, the total number of step levels, how many here? This is the one step level, this is the second step level, this is the third step level. Okay, therefore the resolution of this digital to analog converter response is here the full scale output voltage is how much? It means that the maximum analog signal output voltage is how much here? 3 volts whole by here how many step levels is existing? 3. Then we will get the step size or the resolution of this digital to analog converter is 1. Okay, so in this way we can determining the resolution. Okay, and sometimes they are giving this digital input and they are giving this step size and they need to asking determining the output voltage of this digital to analog converter. At that time the output voltage of this digital to analog converter is V naught equal to, here we are consider the digital input we can express in the decimal form into step size. Okay, or we can multiply to the resolution, then we will get the output voltage. For example, here the input bits is 0 1. So here 0 1 equivalent decimal form is 1 and here the step size equal to how much here? 1. Here we will get the overall output voltage equal to how much? 1 volt or not. So in this way we can determining the relation between the output voltage and resolution of this digital to analog converter circuit. Okay, and other specification is the speed. The rate of conversion of a single digital input to its analog equivalent, that is we are considering as the speed. It means that here we are consider the digital to analog converter circuit and here we are giving the digital input signal is the input and here we can get the analog output signal. So here when we can apply the digital input bit, how much time required for this analog converter circuit can providing this analog equivalent, that time we can consider as a speed. Okay, conversion rate depends upon the clock speed of input signal and settling time of converter. Okay, and other specification of this digital to analog converter is accuracy. Accuracy is defined as the difference between the measured output and actual output. It means that we know that in this digital to analog conversion we are obtaining some measured value and we can expecting some value. Okay, so the difference of this expected value and measured value, that is we are considering as accuracy. Therefore the accuracy of this digital to analog converter is reference voltage whole by 2n minus 1 whole square, and we know that this 2n minus 1 is indicating the total number of step levels in the digital to analog converter response. Okay, so in this way we are determining the accuracy. Okay, and next specification is the monotonicity. A digital to analog converter is said to be monotonic if the analog output increases for an increase in the digital input. It means that we are observing the digital to analog converter response. Okay, here we are consider the digital bits is input and here we can get the analog output signal. Okay, for example, here we are giving the digital input is 0 0 0 1 1 0 1 1. And when we are apply the 0 0 is input, we can get the output is 0 volts. And similarly, if you are giving the 0 1 is input, we can get the output is 1 volt. And similarly, if you are giving the 1 0 is input, we can get the output equal to 2 volts. Okay, so here we are observing the inputs and output. The input signal also be increases and the output signal also varying or increases. So with respect to this condition, we are concluding that this digital to analog converter having the monotonicity. Okay, and other specification of this digital to analog converter is stability. The ability of a digital to analog converter to produce a stable output all time is called stability. It means that, for example, here we are consider the digital to analog converter circuit and here we are giving the input is 0 1, then we can get the analog output is 1 volts. Okay, and after sometimes again we are giving the same input signal, then we can expect the same output. If this digital to analog converter circuit can be providing the same output, then this digital to analog converter circuit have the good stability. Otherwise this system has them unstable. Okay, so in this way we are estimating the stability of the digital to analog converter. Okay, the performance of a converter changes with the drift in temperature and power supply variations. So here this digital to analog converter performance is affected by the changes in the drift in the temperature and power supply variation.